Everyone, I am Rekha Chavan. Today I would like to present a seminar on audio compression. Contains introduction, audio compression and adaptive differential PCM and adaptive predictive coding and linear predictive coding and code excited RPC. First, introduction. Audio and video signals are continuously varying the analog signals after the digitization. Both comprise a continuous stream of digital values. Here each value is representing the amplitude of a sample of a particular analog signal taken at a repetitive time interval. The compression algorithm associated with the digitized audio and video are different from those text and image. Here we describe a section of these algorithms, first relating to audio and then those relating to videos. Audio signal uses the PCM digitization process, which involves the sampling. Next, audio compression. What is meant by audio compression? Audio compression is a type of lossless compression which is amount of data in a recorded waveform is reduced to a differing extents for a transmission respect to with or without some loss of quality used in a CD and MP3. As we saw, the digitization process is known as the pulse code modulation. In this pulse code modulation, it involves the sampling and audio signals and waveform at a minimum rate, which is a twice of a maximum frequency component that made. Next, differential pulse code modulation. Differential pulse code modulation is a derivative of the standard of a PCM, and it uses the fact that the range of differences in amplitudes between the successive samples of the audio waveform is less than the range of the actual samples of amplitudes. Here fewer bits required to represent the different signals than in a case of a PCM for a same sampling rate. It reduces the bit rate requirement from 64 kbps to 56 kbps. We will see DPCM principles. In a DPCM principles, it consists of a two-part encoder and decoder. Here DPCM principle consists of these blocks: band limiting filters and analog to digital converter and subtractor and parallel to serial converter, and here decoder, low pass filter and digital to analog converter and resistor R and adder and DPCM and serial to parallel converter. So we see here block diagram. In an encoder, previously digitized sample is held in the register R, and the DPCM signal is computed by subtracting the current contents of R0, and here the register value is updated before transmission. And in a decoder, this is a decoder. In decoder, decoder simply adds the previous register content PCM pulse code modulation with the DPCM. So adaptive differential PCM. Next is adaptive differential PCM. In adaptive differential PCM, first ADPCM international standard is defined in ITU T recommendation of G.721. Here saving the bandwidth is possible varying the number of bits used for a differences signal depending on its amplitude. Here based on principle as the DPCM, except the 8th order predictor is used in the number of bits used to quantize each difference is varied. So this can be either 6-bit producing 32 kbps to obtain the better quality output than with third order DPCM. DPCM is a differential pulse code modulation, or 5-bit producing 16 kbps if lower bandwidth is more important. So second is second ADPCM international standard is defined in ITU T P recommended by Z.722. Better sound, better sound quality at the cost of added complexity, and with bandwidth is rise to high quality as you need in a video conferencing. Next is ADPCM subband encoder and decoder schematic. The diagram shows the ADPCM subband encoder. The block diagram also consists of encoder and decoder. ADPCM subband encoder and ADPCM subband decoder. Here speech input signal is a speech input signal, and it is connected to a lower subband band limited filter, and this is a upper subband band limiting filter, and lower subband ADPCM encoder and upper subband ADPCM encoder. This lower subband ADPCM encoder represented the 48 kbps, and upper subband ADPCM encoder is representing in a 60 kbps. This connected to a multiplexer. And next, ADPCM subband decoder consists of a lower subband low pass filter 50 Hz to 3.5 kHz, and lower subband ADPCM decoder, it represented the 48 kbps demultiplexer. Same as upper subband, and upper subband it is represented at 16 kbps. Operation of ADPCM, this uses the subband coding, and this coding is signal prior sampling is based through two filters. One passes only signal frequency in the range of 50 Hz to 3.0 kHz, and other only frequency in the range of 3.5 kHz. By doing this, the input signal is effectively divided into separate equal bandwidth signals. First known as the lower subband signal, and second is the upper subband signal. We already see in a block diagram of ADPCM. Second, each is then samples is encoded independently using the ADPCM. Then the use of a two subband has advantages that different bit rates can be used for each, and the two bit stream are multiplexed to produce the transmitted signal such a way that decoder in the receiver is able to divide it then back again into separate stream decoding. Operating bit rates are 64.56 or 48 kbps. Next, it is the adaptive predictive coding. In adaptive predictive coding, even higher level of compression possible at higher levels of complexity. These can be obtained by also making predictor coefficient adaptive. In practice, the optimum set of a predictor coefficient continuously vary since they are function of the characteristic of the audio signal being digitized. The optimum set of a coefficient are then computed, and these are used to predict more accurately the previous signal. This type of a compression can reduce the bandwidth requirements to 8 kbps while still obtaining an acceptable previous quality. This is the adaptive predictive coding. Next, linear predictive coding. In a linear predictive coding, with the coding, perceptually features of an audio waveform are analyzed by the source first, and these are then quantized and sent to the destination uses, then together with the sound synthesizer to regenerate a sound that is perceptually comparable with the source audio signal. With the compression technique, although generated speech can often the sound synthetic, but very high level of compression can be achieved. In terms of speech, three features which determine the perception of a signal by these are its. First one is pitch, and second one is period, and third one is loudness, and fourth one is a voice sound, and another is a one voice sound. First we go for a pitch. In pitch, this is the closely related to the frequency of the signal. This is a